This is CPM Precalculus Chapter 2, number 167. So here we're asked to modify our area program. We called ours curve area without the E because our program only allows 8 letters. Okay? And see how it actually accurately computes the area between our curve and bounded by 0 and 2. Using 100 intervals. Okay, so our program we know asks for the function, right? A, B, and N. Well, our function here is just the square root of 4 minus x squared. A is our starting index, B is our stopping index, and N is the number of intervals or rectangles. Okay. So when you do this, our program's gonna spit out the left-hand area, the right-hand area, and the trapezoid area approximations, right? And we could also go ahead and, if our program is updated, do the midpoint area as well. So let's go ahead and run our program, curve area, run it. So we go ahead and push enter, asks for the function, the square root, again, of 4 minus x squared. A is 0, B is 2, N is 100. Okay, push enter here, and it's going to go ahead and compute these for you. I'm not going to do it because I want you to make sure you know how to run your program. Instead, I'm going to go ahead and edit my program. So if yours is having an error, you can see and change it to look exactly like this. So you can pause this video where you need to. I'm actually going to zoom in, right? Let's just make this screen a little bigger. Okay, hopefully that will help a little bit. Okay, so it starts off, the first line we know it's just clear home, input function equals, right? And then comma, string 1. Where do we get string 1? I'm going to go ahead and do some of these. It's in the variables key, so click variables. String is 7. Go down and choose string 1, right? Press enter. And that's how you get string 1. Do the same way. Store it. Store is the key right up above on, STO arrow, so that's how we store it. In Y1, again, is a variable, but we have to go to the Y vars, so we go to the right, the function variable, and here's Y1, okay? Input A equals B equals N equals, right? That's going to give us all of these inputs right here, right? We initialize KRL, right? KRL. We have a label. Ours is going to be label 8. You can call it what you want. We're going to add L plus W, which is the width, times the function Y1 with the input of A plus W times K, stored into L. K plus 1 is stored into K. We're incrementing K. Our right-hand area plus the width times our function, right, at A plus W times K is stored into R. If K is less than or equal to N minus 1, go to 8. So that's the loop. Finally, we get the trapezoid area, L plus R divided by 2, and store that into T. Display L, R, and T. That's what's going to be displayed after you run the function. Quit when you're done, right? Second quit, and there you have your program. Okay. I'm going to go ahead and add in M right now, the midpoint. Again, I'm not going to solve these and compute this, so make sure it's your responsibility to get these values. I want to make sure you're able to do it. So if you don't know how, either change your program or come see me in person. I'm going to just make this a little smaller so we can see it all. So if I want to add the midpoint area, remember the midpoint is similar to the left hand, the left-hand area we know is just the sum from k is equal to 0 to n minus 1 of delta x, which is our width, times the function at a plus delta x times k, right? To get r, we just do the index from 1 to n. T, we take the average of L and R. Well, M, we go ahead and start at k is 0, go to n minus 1, the same thing as L, delta x. And now, instead of starting at A, we're going to start at A plus 1/2 of delta x, right? That's going to give us our midpoint here. And then we're going to still add in delta xk every time. Okay, so this, let me go ahead and point out what's new. This right here is the new thing for the midpoint area representation. So to change our program, if you want to go ahead and change yours to calculate the midpoint as well, let's do that. So what we should do first is initialize, just like we initialized R and L. Let's insert an initialization for M. So second insert enter, right, is going to give me a space. Now I'm going to put 0 is stored into M. So alpha M, right? Then inside my loop in label 8, I'm going to insert another line here. So at k plus 1 is stored into k, I'm going to second insert enter and go ahead and store. I want to now compute this, okay? So that's going to be M alpha M plus, and then here we go, delta x we know is W, so alpha W times y1, I go to vars, function y vars, right, y1, and a, alpha A. Now I want to add in 1/2 times delta x, which is 1/2 times W. Let me go ahead and plus 1/2 times delta x, which is W, plus W times K. We still have over here, and we know delta x is equal to W in our program, so plus W times alpha K, and this gets all stored into M. Okay? So now we're adding in this part because we know this is making us do the midpoint, right? This right here is important because it helps us find the midpoint. At the very end now, we're going to display the left, right, trapezoid areas, and let's also display the midpoint. So go ahead and program IO number 3 and alpha M. Okay? So now our program is more complete. It's going to display all 4 representations of the approximate area. Left, L for left-hand area, left endpoint rectangle area, R for right endpoint rectangle area, T for trapezoid area, rectangle area, and M for midpoint rectangle area. Okay, so here's our program again. I'm going to scroll through from the top all the way to the bottom, just so you can see. You can pause it anytime you want to. And if yours ever doesn't work, you could check back here and make sure yours is the same. Alright, so then second quit. Let's go ahead and run our programs together. So program, I'm going to execute curve area. Right, I'm going to run it. It clears the screen. The function, I'm not going to do the function here that we're given in problem 167, but I'm going to do another example. Let's go ahead and find the area between our curve x squared and 1 between the boundaries 1 to 5 using n equals 25. Okay, And then this is going to give us L, R, T, and M, right? But this is not, again, the homework question. This is just practicing our function. So x squared is the function. A is 1. B is 5. Oh, this is B. And N is 25. This is just a practice example. So the area under the curve using left endpoint rectangles is 39.4304 units squared. Using right endpoints is 43.2704 units squared. Using trapezoids is 41.3504 units squared. Using midpoint rectangles is 41.3248 units squared. Okay, so you see trapezoids and midpoint are not always the same. In fact, they shouldn't be, right? And that's just an example of using our program. Okay, so go ahead and use your program to find the area bounded by this function, the square root of 4 minus x squared, using these values. Okay, and use 100 intervals means n is 100. And you should get 3 outputs. Unless you modified your program, you should get 4. Okay, so again, this is not the question that's asked on the homework. I'm not going to do that because I want you guys to make sure you can use your calculator. And you can check your answer or your calculator by seeing if you get these outputs here using this example here. Okay, so that's going to end for us the review of CPM Precalculus Chapter 2, number 167.